Thank you all folks for joining today. As you can see, my name's Derry, and today I'm going to be walking you through how platform teams can enable true self-service for developers using an internal developer portal, using CircleCI, and also leveraging Terraform. Now, one thing to note is that you do not need an internal developer portal to basically go through or set up a similar setup to what we will see today, but we're just showing you how you might want to leverage one. So as I mentioned, my name's Derry, and I'm part of the field engineering team here at CircleCI. I've been working here for about 4 years now, but I've been working in the platform team space as a platform engineer or a DevOps engineer for roughly about 6 or 7 years right now. Bit of a fun fact about myself. I did work in construction across Ireland, Toronto, and other cities in North America before my career in software engineering. And I do think some of you folks have already started to share where you're dialing in from, but feel free to share your current role and to get maybe your favorite local beer if you feel comfortable sharing that as well. So moving on to what we're going to walk through today. We kind of had our kickoff and intro already. We're going to quickly address the problem that developers face and who are blocked by platform team or platform workflows in general. We'll then get straight into the self-service experience demo. We'll have a look at the infrastructure as code setup, and we'll also take a look at some guardrailing capabilities that are available to you through CircleCI. And then at the end, we will open up Q&A. So feel free to drop questions in the chat, as Carla already said, or in the Q&A section, and we will have plenty of time at the end to address all of those questions. So no worries there. So the problem and the developer pain that a lot of folks, or that we're looking to, I guess, alleviate with this demo today. So I want you all to imagine that you're a developer spinning up a new service in your organization today. What do? Do they ping a centralized platform team on Slack, maybe open a Jira ticket, and then they might have to wait, sometimes a day, however, sometimes maybe 2 days, maybe even longer, up to a week, because the centralized team has to go wire up secrets, repos, pipelines, etc., and of course roll out those repos with kind of best practices and organizational standards in mind. As I'm sure we've all experienced in the realm of software engineering, this is a very slow process and it can be tedious for developers. Again, pinging somebody on Slack, filing a ticket, and then waiting for that infrastructure to spin up. And that's before we've even thought about CI/CD. How do we get those repositories? How do we get those projects up and running? It might be copy and pasting code. What it isn't, though, it isn't rolling out best standards across an organization or enabling our developers to start delivering value to their customers as quickly as possible. And today, we're looking to fix that problem. So one thing I just want to highlight is what happens if we don't try to solve this problem. Well, first off, for developers, the time to value is delayed. They lose days waiting for environments to be spun up, pipelines to be wired, secrets to be provisioned. And as I mentioned already, this is time, not shipping value. Secondly, when platform teams can't move fast enough, developers are going to go DIY. And I'm sure we've all experienced that in our careers at different points, which leads to no consistency and no guarantees. Third, it can lead to platform team burnout, as every new project needs a new ticket, a Slack thread, a manual setup, whatever kind of the process is in your organization. And then your most experienced platform engineers end up doing ticket ops, and that's not why they were hired. And finally, the last thing to point out here is security risks. So when governance takes too long, teams will find ways to go around it. That's what engineers do. When you've got unknown repos, now basically you might have unknown repos, unknown pipelines, and potentially wide open deploys. So this isn't just a DevOps problem, there's an audit risk problem here. And this is why self-service isn't the nice to have, it can be table stakes for your organization. So quick overview of the tooling stack that we're going to use for this demo. We're going to leverage Port as the UX here. And port is going to be our IDP. So an IDP is an internal developer portal for folks who are unaware. You could use, we're using port, you could use Cortex, you could use Backstage, you could use a homegrown solution, or you could just leverage CircleCI to trigger all of this process. But orgs are starting and platform teams are starting to leverage and roll out IDPs. Hence, we're just using that as a UX for this demo. We're going to use Terraform as the orchestrator, and then CircleCI is going to be the automation engine under the hood, automating all of the processes that we see. So now we're going to get straight into the demo. So instead of filing tickets, the developers will come to port. Okay, this is where they'll come to use a self-service portal to set up and provision the projects with CircleCI configuration out of the box. I did mention you can use any IDP here, so it does not need to be port, and you could just use CircleCI just to drive that point home. So a developer will go to a self-service port action, hit create, choose the template that they want. Let's say a developer wants to set up a Python project or a Python service, and we'll give it a name here, something like developer login service. We'll hit execute, and now it's coffee time. So in about 2 minutes, everything's going to be ready to go. The automation will create a GitHub repo with boilerplate code and CircleCI templating built in. And again, why did we set up this process as a platform team? Because we want developers to operate what we say above the value line. Focus on delivering value to their customers and let the platform teams handle this piece as much as possible. Under the hood, what we will see, under the hood, what we'll see in CircleCI is that a provisioning pipeline. Port sends a webhook to CircleCI to trigger a provisioning pipeline. And let's take a look at what that pipeline running is doing in CircleCI. So we'll jump straight in. And this pipeline is going to leverage Terraform under the hood. Excuse me. It's going to leverage Terraform under the hood, which pulls in a GitHub repo template, which has best practices defined by our organization built in, and also some boilerplate code. So this is the starter template that we're basically going to recreate for the developer. And again, built in with kind of PEP standards, unit testing with PyTest, Docker support for containerized builds. And you'll also notice there's a CircleCI folder up there. We'll take a look at what's in that later on in the conversation. It's then going to set up that project. It's then going to set up that project on CircleCI. Okay, and this here we can just see the Terraform logs as we're setting up this project. As I mentioned, it'll set up the project on CircleCI. It's going to provision context, which are shared secrets at the organizational level on CircleCI. The Terraform will also set up pipelines and triggers on CircleCI, and it's going to wire up these pipelines leveraging config templates or centralized config management. We'll dive into that in just a few moments. But the thing to highlight here is all of this is infrastructure as code. No CLI or no manual steps. We'll take a look at the infrastructure as code as well a little later on in the conversation. But if I go to my, just moving some Zoom boxes out of the way here. If we go to my organization home for my CircleCI org, we'll see that the dev login service project has been created. We'll just jump in to take a look at what that looks like. And we'll look at the pipelines for this project. Okay. Looks like the Wi-Fi is being a little bit laggy, so I do apologize there. Just there we go. We can see, and what you'll notice is that so the project has been set up, it has been configured, and we did send an empty commit to kick off the first build. We just did that to show that the project is live. Let's take a look at what the pipeline entails. So we can see that there's 3 jobs in this one pipeline in CircleCI. And let's take a look at the workflow. So your workflow in CircleCI is basically your job orchestrator. And each box that we see on the screen now is its own job. We have a build job, a test job, and a deploy job. Okay. And we can see here that there's a dependency matrix introduced. So our test job and our deploy job aren't going to run until the previous job has complete. And if we jump in quickly, we can see here We can see the resource class that this job has been executed on. Now, this could have been a Docker image, it could have been a Mac OS environment, it could have been Android. You could even bring your own self-hosted runner here. And then we can look at the individual steps that each of these jobs, each of these individual steps, I should say, that make up this job. So what we've seen so far is we saw the CircleCI project has been created, and we saw that a workflow has run. Now, how did this happen? This was all orchestrated from this centralized repository called the platform teams config. Okay, so we have all the Terraform code leveraging the CircleCI Terraform provider lives in here. Policies for an organization, orbs, which is one way to share config in CircleCI, and even some documentation. But one thing I want to show you and really highlight is that it contains standardized language-based CI/CD templates. Okay, let's take a look at what we have going on in here. We've got a baseline one, we've Docker, Node.js, Python. We created a Python project, so let's jump in to take a look at what is in that config. We can see workflows, which is our job orchestrator, which we already saw in our UI. And we see each job that is defined inside this centralized repository. Okay. What you'll notice here, however, is that there isn't really anything meaningful happening in this job, in each of these jobs. All the build, the test, and the deploy job is doing is echoing something out. Okay, but what you'll notice in the workflow area up here is that each job has been given an override key. Okay, and if the job in the centralized config provided by the platform team has an override with key, that means the developer application that is going to inherit this config or leverage this config as a baseline is able to override that job or customize that job. I'm going to say that one more time. So any job in this centralized config that the platform teams enable an override with key on, the developers or the developer application is going to be able to provide a customized version of that job. And this is really important and very powerful, and maybe even more powerful if there wasn't an override key there. So you can imagine from a security or from a guardrails perspective, if the platform team wants to enforce what the developers can actually customize, they just don't provide an override with key. So if you're thinking governance gates, jobs, security scans, whatever it might be, if this centralized platform team wants to provide a blueprint or guardrail how they can deploy to a certain environment, let's just not provide that override with key here. Okay, so again, some very powerful stuff there. I'm sure you can all start to imagine with this templating and override capability that we have here at CircleCI. And if I jump over to my organization, where that developer repo that we created from port should be, what we can see is that that repository has been created. We'll jump in to take a look at. As I mentioned at the top of the call, this is just a copy of that starter template that we looked at earlier on. And again, what that consists of, what the developer will get to be up and running is quite a bit, actually, all the stuff that we walked through at the top of the call. But what we did for the purpose of this demo, we also created a developer config. So we can imagine that the developer goes in and they want to override a couple of those jobs that we just looked at. So what we can see here is that the developer has customized the build job, and the developer has also customized the test job. What we can notice is that they didn't provide a customized instance of the deploy job. Okay, so what does that look like if we jump back over to the user auth service application in if we jump back over to the developer login service in CircleCI, we look at the workflow again. What we can see is it looks like there's something actually going on here in the build and the test job, and the deploy job is just going to be whatever was inherited from the centralized location because the developer didn't provide a customized instance of that job. The test job, we can see, that there are some meaningful steps because the developer decided to customize it. And if we jump back again and into the deploy job, what we're doing here is just inheriting that version of the job provided by the platform team, which in this case was just a echoing out of just a simple echo of a message. So again, some powerful stuff there. And again, just to show you, if I go to the application setting, if I go to the project settings for this project, I look at my project setup, we can see the config source is actually that centralized location. It just points to the config file path in that centralized location, owned, maintained, and hydrated by that platform team. But checkout source is the developer project. Okay, so when a change is made to this project, we're going to start seeing builds triggered in this application, but the centralized config source is where the main config lives. We can see in this case, we've just used the Terraform provider to set up a trigger that just triggers on developer login service, but you could set up multiple triggers and different things based on different Git events, as you can see here. Or a custom webhook. So any platform that can emit a webhook, CircleCI is going to be able to ingest that and trigger a body of work on CircleCI. So from the devs perspective, they basically went from an idea to running a pipeline in just 2 minutes, which is absolutely awesome. Okay, there's no tickets, no waiting, and the platform team can focus on doing what they do best without needing to lift a finger. It's scalable, it's self-service, and it's secure. This is platform engineering done right. We have Port as the UX, Terraform as the orchestrator, and CircleCI as the automation engine. Developers move fast, and platform teams stay in control. Everybody wins. And just to highlight these things here again, developers don't need to wait. The platform teams didn't need to handhold. Guardrails and best practices are baked in. And finally, you get velocity and governance together. And that's the win here. Hence the key messaging of this platform team toolkit that CircleCI has released. You can see the platform team's toolkit features at the bottom, but really what we want to take to our customers, or give our customers the ability, is to stop choosing between an organizational control and agility. You can get both here. This, as I mentioned, are all part of CircleCI's platform team toolkit. You can scale without sprawl, you can implement governance without gridlocks, and you can unlock developer autonomy without burden. So just looking to see if there's any questions so far. I don't think so. So that's the demo, but let's start to dive in to how we were able to do that just as code, as infrastructure as code. So the first thing I want to do is kind of orientate you with the repository. So you can see the config templates. This is the centralized repository that the platform team is going to be able to roll out. You can see there's config templates in there, the docs that the platform team provide, orbs, another way to share config in CircleCI, which again, you can feel free to ask me any questions about. Policies, we'll take a look at what they are soon, but let's take a look at the Terraform code. Okay, so first off, the Terraform provider is basically going to be stored in this location. And this also holds input variables and provisioning logic specific to CircleCI. However, the core Terraform logic across providers, in this use case, we use the provider for CircleCI, for AWS, and for GitHub. And this structure makes it easy for platform teams to manage a reusable pattern, and then for app teams to onboard fast without low-level concerns. As I mentioned, the provisioning will start up here in our app.tf file. And all you can see here is we've got a couple of key blocks. The org.info block just sets the CircleCI org context basically. And then in our app pipeline profiles, this is the main block describing the app. For example, the app name, which config template to use, which context to create for sharing environment variables within CircleCI, and maybe any context restrictions. So maybe you don't want secrets to be available on every branch, just the main branch for production secrets, those kind of things. Okay, but the main Terraform logic, as I mentioned, is going to live down here in our main file. This is where the provisioning actually happens. So when somebody fills out that form in port, in this use case, or it could have been CircleCI as the UI, and they click create project, or execute, I think it was in port. Here's exactly what our Terraform does behind the scenes. So first, Terraform gathers all the information it needs. It gets GitHub info, repo info, gets existing CircleCI contexts, figures out which config template to use, etc. And then the second part is basically the provisioning of the project on CircleCI. So it creates the CircleCI project for the new application. It creates a unique context for that project, and then it injects environment variables securely into that context. So those secrets live in that context, which is available across the organization, depending on what context restrictions you put on, which you can actually see here, that this is where we started, I guess, implementing context restrictions. So tying access to specific branch rules. I think it adds project level restrictions also, and then it also configures some user permissions for those contexts. So who has access to what secrets? And then it creates the pipeline on CircleCI. So this is where I guess CircleCI actually starts building the actual pipeline. So we're defining the pipeline using the config.yaml from the right template folder, points to the newly created GitHub repo, and then everything is connected automatically under the hood, and again ensures configs are versioned and fully traceable. So the developer gets a working pipeline that follows all of our organizational standards, but they didn't have to learn CircleCI configuration or guess best practices. And the final thing is it sets the default trigger, which we also got to take a look at. So a push to main will automatically kick off any CI/CD pipeline. And that's it. In about 2 minutes, we've gone from submission to a fully functional development environment, CI/CD, security controls, and best practices all built in. I see one question coming through here, how the Terraform state is being managed. We are going to address that, but we're leveraging AWS under the hood, which I can probably point to now in the provider section. We're leveraging AWS and we're leveraging S3 under the hood here when it comes to managing Terraform state. There's DynamoDB locks to prevent concurrent deploys, etc. And this is a really good setup for shared use by multiple engineers and for automation. And to connect into AWS, we're leveraging OIDC under the hood, so there isn't actually any secrets need to be stored in CircleCI, just to highlight that also. So moving on to our guardrailing capabilities. Okay, so I guess this story is we've really shown you so far how to make developers move fast with self-service provisioning, but here's the critical question. How do you maintain security, compliance, and standards when everyone can go and create their own pipelines? The answer is guardrails, and not the kind that slow people down, but the kind that keep them safe while they want to move fast. And I'm sure we've all kind of had to grapple with this in our organizations. Either with traditional governance, things can be too rigid, developers are going to go and find workarounds, or if things are too loose, that leads to security and compliance drift. So we need guardrails that are automatic, invisible, and impossible to bypass. The first guardrail, or the first kind of guardrail on CircleCI that I want to introduce us to, is the idea of, configuration policies. We did notice in our structure early on that we do have a policy, directory in here. So each of the policies that will live on your organization are going to be organized by concern. So here's our Python version policy. Okay, this is written in Rego, the policy language that powers open policy agent, and config policies on CircleCI leverage open policy agent under the hood to enforce those policies on your organization. Basically, any policy that you have on your organization active, if you try to push through a config or a CircleCI config that does not comply with those policies, you're going to be able to do a soft failure or a hard failure. And what we can see here in this pipeline that was triggered on the developer service is that there was a soft failure for this developer. So that means that the pipeline still ran, but it did give a warning to the developer to say, hey, your config did not comply with our policies, and let's make sure that we're up to date for the next one. So basically, it's a soft policy. It didn't break the build, it educated the developer. And that means developers get instant feedback, the builds can continue to run, and the platform team gets visibility into compliance. No real productivity blockers. But what I do want to point out to you is what a hard failure looks like, just in case you do want to completely make sure that the developer doesn't put through something that they should not. And in this use case, we can see here that the developer tried to leverage a production context on a development branch. And because they did that, there was a hard failure. Again, it's Friday afternoon, your developer wants to get something out to production without having to go through a review or a PR process. We've all seen it, we've all been there, and it breaks build, it breaks production. So we want to ensure as a centralized team that developers can't do things like that. So some very powerful use cases when it comes to config policies there, the hard failure and the soft failure, again, all leveraging Open Policy Agent under the hood. So now I want to quickly talk about secrets on CircleCI. So when you're leveraging CircleCI for secret management or environment variables that live at the project level, you're going to get a fully fledged KMS out of the box, leveraging HashiCorp Vault under the hood to store secrets at the project level. Okay, so just to highlight that, however, you can also store secrets at the organization level, and those are called contexts, which we'll get into in just a moment. But maybe you don't want to store secrets on CircleCI. What you can do is you can bring your own vault and you can leverage OIDC to connect into Vault. And we see a lot of customers using that in their production environments today. And we're actually using OIDC in this instance to connect into AWS. The reason that we're connecting into AWS and leveraging OIDC is, as I mentioned a few moments ago, is to store our Terraform state. So Terraform state is stored securely in S3 with DynamoDB locks for concurrency. And as I mentioned, the key here is that CircleCI never stores permanent AWS credentials. We're leveraging OIDC to provide temporary tokens that expire within minutes. They can be scoped to specific actors and they leave a complete audit trail. So this can create a complete passwordless infrastructure for platform management. And the reason why it also can, going one step further, when you do need to leverage secrets or you would like to leverage dynamic secrets, you can leverage OIDC to connect into Vault and then leverage the dynamic secret capabilities of HashiCorp Vault there under the hood. One more thing to also point out in terms of guardrails is the idea of contexts. So I mentioned if you do store secrets or environment variables in CircleCI at the project level, that's leveraging HashiCorp Vault. You don't need to manage a KMS under the hood there for that. However, maybe you want to share secrets or share environment variables. Looks like my internet is playing up here a little bit, so I do apologize, but I can just use this view to show contexts. So again, if you want to share context, share secrets across your organization, you can share them and store multiple secrets within a single context. And these let us implement defense in depth and are much more powerful than just a standard secret store, as they basically they're a complete access control system. So what we can do here is that we can set specific project restrictions. So each project gets its own isolated contexts. We can introduce the idea of branch-based secrets here. So if this context is accessed outside of a main branch, let's block the build or let's not enable that. We saw how we can leverage config policies to do that, but we can also just do that at the context level itself here. And what that means is that feature branches get development contexts only, main branches get production contexts, and there's no manual approval needed here, which is absolutely great. And again, what I just want to highlight also in terms of our guardrailing story is the idea of config templates. My internet is playing up here. I do apologize about that. The idea of config, centralized templates with overrides. So templating and overrides. We looked at that demo already, but they're not just for convenience, they're also for security controls. Okay, so every template can include, for example, a dependency vulnerability scanning, static code analysis, container image scanning, whatever it might be that you want to enforce, and just don't give the developers the ability to override those jobs. And I'm sorry if there's any developers on the call who might take offense to that. But again, those non-overridable steps. And again, this is great for compliance reporting, as every pipeline automatically reports which template was used, what customizations were made, security scan results, deployment approvals. So I know I've been talking for quite a bit. There is so much more of the CircleCI platform that I would love to dive into with. But one thing that I might just show, I know we're at 33 minutes, is the idea of a provisioning or a deprovisioning pipeline then. So if I jump over to my platform team configs, and let's just say we don't want to use CircleCI, or we don't want to use an IDP like Cortex, like Port. Let's just use CircleCI's GUI to trigger this process. I go to my platform team's configs, I go to main, I'm going to go to trigger pipeline. I'm going to use my deprovision pipeline in this use case. Okay, so in this project, we've got 3 pipelines: a provision pipeline, a deprovision pipeline, a config policies pipeline. And all of these, am I in the right project here? I hope you're looking at my my IDE here, cursor. You can see that each config file has its own individual YAML file. And as you should already know from this conversation, that these configs don't need to live in this repo. One thing to also point out while I'm just here is, from a developer's perspective, all of this can be tracked from here, from within the IDE. They don't need to context switch and go over to CircleCI to get the outcome of an individual pipeline. They're able to get it all from within here. Again, speaking to the developer experience. On the right hand side, what you can see over here is that earlier on, when I was in this project, I was leveraging the CircleCI MCP server to interact with the outcome of pipelines. So just to highlight those things as well. Some super useful features for the developer experience side. However, I want to trigger a pipeline from CircleCI. My deprovision pipeline, all I need to do here is give it the name, and the name of the repo was a developer login service. And again, that deprovisioning is going to deprovision everything that was set up in that CircleCI provisioning pipeline, leveraging the CircleCI Terraform provider. So again, this is just going to run a Terraform destroy on all of those resources that were set up and created. So I guess to conclude, before I open up Q&A, I want to thank you all for joining the call today. What we were able to show was a modular, repeatable, and secure way to bootstrap new teams on CircleCI using Terraform and GitHub. And in just one Terraform apply, we were able to create a new GitHub repo from a predefined template, set up that new project on CircleCI wired to that repo, automatically apply context level secrets and access restrictions, enforced best practice config and policies, and then we even kicked off a pipeline to verify that it's all wired up. So I'm sure you're all able to see how this can give platform teams a consistent setup process, confidence that secrets are scoped securely, and a fast path to production for developers. And why this matters is because you reduce hand-holding and ticket churn for those platform teams. You apply least privilege by design, and you can centralize config while still giving teams the velocity that they need. And just to note that this pattern works for onboarding one project or 100 projects. And again, thank you all very much. We're going to open up the Q&A now, so I'll answer any questions that I missed throughout the process. And if you'd like to hear more, we will follow up tomorrow, I believe, Carla, with any follow-ups that we need. Yeah, again, thank you all for joining today. I really appreciate the opportunity to show off our new platform team toolkit here at CircleCI.
Thank you so much, Derry. That was a very interesting presentation. So jumping into the questions, guys, remember to share them in the chat or in the Q&A section. I do see we already have some questions. Kevin is asking, I think it's related to the demo. What about organizations that generally have all their services within a single repo? For example, where I work, we have around 200 services within a single repo, and it's great. Can IDPs like port support that kind of templating, or this is only really work for multi-repo setups?
That's a very interesting question, Kevin. The demo that I set up, or that my team, the field engineering team at CircleCI was configuring today, was definitely around a multi-repo setup. But I'm just thinking for a standard monorepo use case, let's say you have a front end, a back end, some kind of data layer in there as well, and you want to create a docs layer. I'm assuming what you're saying is, can we just inject that if a developer wants to add a new service to that repository, would that just inject into, could we leverage the CircleCI Terraform provider to just inject another layer in there? I'm not sure if the provider would be able to do that today. It might be. I'd have to dive in a little bit deeper, but it's a very good question, and I'm actually going to take a note to see if that's possible because, yeah, like we have a lot of different monorepo capabilities at CircleCI, like which are just being able to run if a certain path has changed, a certain file path has changed, etc. Um, but the ability to just provision something into that repository is a good question. It's something that we can definitely take a look at. So appreciate the question. And yeah, I'll follow up with that. Maybe Carla, if we can just take note of, I think, Kevin Johnson. So yeah, we'll be sure to follow up with that.
I'll save his contact. Um, yeah, well, next question. Stephen is asking, we have a large amount of Terraform models to enforce best practice and minimize DevOps engineer effort when writing consumer Terraform code. Our role dependency flow is platform engineer, DevOps engineer, and developer. In this type of IDP setup, I assume we will need to provide the consumer Terraform for the IDP with overridable values.
Correct. Correct. Yes. So in this use case, to override the values, the default values that need to be overridden in the Terraform modules, um, again, each IDP is going to be different. This is port, Cortex, Backstage, whatever it is, or even in CircleCI. So I think if I walk through the CircleCI model first, actually, if you just wanted to use CircleCI as a UI, what you're able to do is provide all of the environment variables that are needed when you go to trigger a pipeline. But in port, what you can see here is for a self-service action. If I go to edit, I think is it in the back end. Yeah. So here are the different variables that basically need to be overridden in the template in the Terraform code. So yeah, all of this is needed to be provided in this self-service action from the IDP.
Thank you so much. I don't see any new questions. Let's give it a minute, guys. If you have anything, ask. It's your time.
Sure. And I guess just while we're waiting, there's a lot of resources, and Carla, I can share these with you to make sure that they go out to the folks in terms of YouTube videos that walk through everything I just walked through there in about 5 minutes, obviously in a lot less detail. We have some blog posts, some different kind of tutorials, etc., that will be coming out so you can set up a similar setup extremely easily. We're going to make all of the repos that I walked through today with you public. So you will be able to just fork the repo and get all of this set up, and set this up on your own CircleCI organizations extremely easily. So, and we're going to write a tutorial in the next week or two, so you'll be able to just follow along and get that set up. So that should be awesome as well.
Thank you. Yeah, I see Alexander is asking a question. How to reapply configuration to end projects? Is that possible? I understand that one project has one state.
One project has one state. Reapply config to n projects. Alex, are you talking about CircleCI projects there, or are you talking about the Terraform state? Just to clarify, if you can hear me, Alex. The Terraform state. So what's going on under the hood is basically that the Terraform state is being stored, as I mentioned already, in S3 with DynamoDB locks for concurrency. So I think it's the DynamoDB locks there that will enable that concurrent capability of storing the Terraform state.
Okay, thank you. Do we have any more questions, guys? Let's see. Well, okay. So if you do have any questions after this webinar, remember to share it with us in the Slack and we will make sure to answer them. But yeah, thanks, Derry, for the amazing presentations, and thanks everyone for joining. Remember, I'll be sharing with you the slides and recording. And yeah, thank you and have a great rest of the day wherever you are. Bye, guys.